the news means like all over the news, it's around China and Russia building hypersonic vehicles. And what they say, US is right now very far away from hypersonic vehicles, but I don't think so. So what is this politics about? What is this going on right now?
So, I guess to kind of preface this, the reason hypersonics and as a field is incredibly important right now is because there's been sort of a dogmatic shift in militaristic approach in the past decade or so. In particular, the way weapons are deployed. Previously, they were deployed using mostly stealth. It's definitely possible. If there are aliens and they've come to this planet, right, from, who knows how far away, their
Hmm.
technology is most likely like so advanced that,
Hmm.
we probably can't even see them or cannot detect them of any sort.
Hmm.
So, I mean, if they wanted to be detected, then they would be detected. But
Oh.
if they're so advanced, then how would we even know that they are there, right? At times the speed of sound. And so
Hmm.
generally in that speed regime, you have
Hmm.
very high temperatures, you have chemical reactions upon the surface of leading edges in aircraft and the noses of various aircraft at those speeds.
Hmm.
You also have oxidation that occurs rapidly in the upper atmosphere as a result, thermal ablation of materials and um, upon very sensitive optoelectronics and
Hmm.
electronic equipment and communication equipment.
Hmm.
And so having ceramic materials, which have a lot of compressive strength, a lot of thermal resistance, high melting temperatures, and aluminum oxide, for example, is refractory oxide, has no risk of oxidation in the atmosphere as a result.
So in this podcast, I have with me Ashwin. Ashwin, tell me about yourself a bit.
Yes, hello, Mahindra and Mahindra's audience. Thank you very much for inviting me. I'm very grateful. Now, my name is Ashwin. I was born in Madras and came to this country with my family when I was very young, at 1 year old. I grew up on the East Coast in Northern Virginia, which is where I've been most of my life. And I was very interested in space and aerospace and astronautics. And so I went to Purdue University in Indiana, which is where I am now for both my undergrad and now for my PhD, which I am in the process of completing. I did my undergraduate in aerospace engineering, and I'm doing my PhD now in material science and engineering with a focus on ceramics processing for hypersonic application.
Okay, okay. So for my audience, you're funded by US. You're funded by Purdue, or are you funded by US Army folks, something like that?
Yes, so I contracted with the US military in 2018. And so ever since they've paid for the majority of my tuition for undergraduate. I applied for a particular graduate scholarship program within the Air Force known as the Developing Airmen We Need program. Uh,
Hmm.
the abbreviation is Dawn ED. And
Okay.
so I had a spot in that program.
Hmm.
I won a spot in that program through
Hmm.
some opportunity. And I basically was able to get a PhD funded through the military at
Okay.
Purdue University as a result.
Okay. Can you tell me more about your research and research title and what you do in that research and what are your objective and research goals?
Of course. So the research I do is very heavy in ceramics processing. So I work with ceramic oxides, refractory oxides, for the purpose of hypersonic infrared windows. Now, what I do is work in particular with aluminum oxide, and I work with it in polycrystalline form. I sinter these powders using various different methods and profiles, and I manually grind, polish, and do transparency testing, microscopy testing, and thermal resistance testing on these types of materials in order to simulate their effectiveness in a hypersonic environment.
So for as people know about hypersonic means like they travel, 5 times the more the speed of light. And what could be the challenges a material can face in that environment?
I don't know about 5 times the speed of light, but it's about five
No,
times the
speed
speed
of
of sound.
sound.
Yes,
Sorry,
yes,
it's not speed of
yeah.
light. Okay.
Yeah, so hypersonic is generally designated as about greater than Mach 5,
Okay.
or 5 times the speed of sound. And so
Hmm.
generally in that speed regime, you have
Hmm.
very high temperatures, you have chemical reactions upon the surface of leading edges in aircraft and the noses of various aircraft at those speeds.
Hmm.
You also have oxidation that occurs rapidly in the upper atmosphere as a result, um, thermal ablation of materials and um, upon very sensitive optoelectronics and
Hmm.
electronic equipment and communication equipment.
Hmm.
And so having ceramic materials, which have a lot of compressive strength, a lot of thermal resistance, high melting temperatures, and aluminum oxide, for example, is refractory oxide, has no risk of oxidation in the atmosphere as a result. Uh, ceramics like that have a lot of potential to be used in these types of hypersonic applications. And so
Okay.
these
Do
are the
you
kind of
think?
environments we're dealing with.
Okay. Do you think they will act as a filler, or they will constitute the entire? They will make up the entire hypersonic, missile or hypersonic vehicle. It's a part or the fully you have to design the using that material, because there are challenges related to lightweight weight of the definitely the missile, and it is supposed to be very less, because composite materials have higher density as compared to carbon fibers and all. What are the trade-offs over there then?
Yeah, so maybe I should explain a little first. Basically, ceramics are used in these applications not as a building material. They're used as a material that's used to separate the aggressive aerothermal atmosphere from sensitive optoelectronic equipment within very sensitive locations on either a hypersonic aircraft or hypersonic missile or radome. And so basically, whether you have a radio frequency or infrared frequency upon which you're communicating, you have various different atmospheric windows. Um,
Hmm.
and
Hmm.
frequencies upon which military and other ground based locations might communicate.
Hmm.
Um, Based on that, you need certain amount of transparency for these kind of ceramic materials. Personally, I work with transparency in the near to mid infrared range. And
Okay.
so it's important for me to make sure that I develop these kind of ceramics that are transparent in these ranges while also being strong enough mechanically and resistive enough thermally, such
Okay.
that they're able to protect sensitive electronic equipment um, on these locations like
Okay.
leading edges on aircraft. So it's not like a building component. Basically, it's
Okay.
more of a uh, transmission communication component that also has the benefits of protecting certain parts of the aircraft and that are more important uh,
Yeah.
for
Yeah.
missile
Okay.
seeking, for thermal guidance, for these
Hmm.
sorts of applications.
Yeah, means like I remember I was watching this video, and I have done a podcast on like basically astrophysics and astronomy, and there is this NASA solar probe, and which is going into the sun's corona, made by NASA. It the protective layer which protects the all the transmission kind of equipments is made up of ceramics and some coating of ceramics, something like that. I think you are talking about that. Apart from that, what do you mean by transparency? Means like when we talk about transparency, we talk about visible transparency basically, but it's not because visible is also some part of spectrum. But when you talk about transparency, it's about to particular frequency in which you wanna operate in. Yes.
Yes. So what that means, so all materials have, they can either transmit light, reflect light, or absorb it, right? Or
Hmm.
scatter it internally or
Hmm.
externally due to backward scattering or internal scattering.
Hmm.
And so when it comes to the transparency range in which you're dealing with these specific materials, the atoms, the actual interaction of these materials with light
Hmm.
and the type of material determines how transparent it would be and in what range it would be.
Okay.
And so certain materials are very transparent in the visible range, and some materials are very transparent in other ranges, like the radio frequency ranges or in infrared ranges. And so what I deal with is I deal with particular alumina ceramics that I work to try to get as transparent as possible in the near to mid infrared range,
Hmm.
which is
Hmm.
about I'd say zero point 0.7 micrometers to about, I don't know, 2 or 3 micrometers in wavelength.
Okay, okay, okay. Because when you talk about when you said transparent, the only thing which comes to mind is like visibly transparent, like glass.
Hmm.
However, it could be at different frequencies. What challenges you face generally? Because there should be a metric. Because I can see means like when you talk about visible light, I can see by glass. Okay, how much transparent it is. What are the
Hmm.
metrics which you say? Okay, now I have made 100% transparent, or something of that sort transparent. What all equipments are required to test your transparency
So
on
a
those
material can never
frequency range?
be
Sorry.
so a material can never be 100% transparent,
Hmm.
because when you're dealing with the refraction of light through a material, you're always going to have some sort of loss due to that refraction. So unless it's from vacuum to vacuum, in which case there's no refractive medium, then you will never have 100% transparency. So it's theoretically impossible. And depending on the material and and the index of refraction, you will have a higher or lower theoretical maximum transparency.
Hmm.
So sapphire window, for example, which is single crystal alumina, I think has like a maximum possible theoretical transparency of like 89% or something. I could be wrong,
Okay.
but I
Hmm.
believe it's within the high 80s.
Hmm.
And so, that's like one such example. Now, the kind of problems I deal with in trying to maximize the transparency of my materials is one, you have to have a material that's very pure. And so the more impurities you have in the material, that leads to more porosity
Hmm.
within the ceramic material. And when light travels through and passes, it
Hmm.
can be internally reflected and scattered as a result. And so you lose total transparency at the end of your transmission.
Okay.
Yeah.
Okay, okay, okay. So I got means like in order to means like safeguard your electronic equipment which are used for transmission and collection of data and all, you need these transparent materials. So what do you think, how what is the progress of United States towards building hypersonic vehicles? Because you can see in the news means like all over the news, it's around China and Russia building hypersonic vehicles. And what they say, US is right now very far away from hypersonic vehicles, but I don't think so. So what is this politics about? What is this going on right now?
So I guess to kind of preface this, the reason hypersonics and as a field is incredibly important right now is because there's been sort of a dogmatic shift in militaristic approach in the past decade or so. In particular, the way weapons are deployed. Previously, they were deployed using mostly stealth and stealth bombers and such. However, in modern day, technologies like hypersonic technologies and hypersonic weapons are able to deliver, missiles or some sort of national threat, an agency for a military power on the that can travel many thousands upon thousands of miles across the globe in a matter of a couple of hours. And so this is like a very, very powerful sort of technology that, of course, in this decade, many various countries around the world are trying to improve upon. Now, countries such as obviously the United States are one. There are a couple of global superpowers that have um, said that they have this sort of level of hypersonic weapon proficiency. The U.S. is one, China is one, Russia, India, and there are many other countries these days as well. That includes Germany, Australia, and a few others as well. But kind
Okay.
of that's what we're looking at as to the shift and the importance of hypersonic weapons in today's age.
So you mean to say, when you talk about hypersonic vehicles, are you talking about it will be how far away from ground it will be like traveling? Is it in lower Earth orbit, or just like a missile in the troposphere, or it could be anywhere? There is no restriction for hypersonic missiles as such.
So I think in general, the way it has to work, um, in order to get the trajectory it needs, typically these missiles are launched into the upper atmosphere, where
Hmm.
first of all you have less drag because
Yeah.
the atmosphere is a lot thinner, right?
Hmm.
Um, and therefore that also reduces the travel time
Hmm. Hmm. Hmm.
for these missiles as a result. And so Most of them are typically used within the upper atmosphere. Now,
Hmm.
again, any hypersonic missile, as long as it's above
Hmm.
Mach 5, is considered a hypersonic weapon. But
Hmm.
I believe most of them are used in the upper atmosphere. There could be some that I'm not sure about that are
Hmm.
used in different locations. Some may be used in space, go through space and then come back down into Earth in reentry. But most
Hmm.
of them are used in the upper atmosphere.
Okay, so this thing you mentioned one thing about stealth
Mhm.
shift, paradigm shift from being stealth to more like towards faster moving hypersonic vehicles. But I consider means like hypersonic vehicle in that way are stealth. For example, radar, which are used for tracking missiles or jet fighter or something like that. If there is something very fast, it won't be visible in the radar spectrum or in the radar, imprint onto the computer and all. So what do you think means like why you consider this detached from stealth? It's a part of stealth, I believe, hypersonics being faster. Don't you
So I
think
guess
so?
let me answer this with an analogy I think that'll really help elucidate. So when you're
Hmm.
playing maybe a chess match, say me and you are playing chess, and you
Hmm.
have unlimited time, right? No
Hmm.
time limit whatsoever when you're making moves. And
Hmm.
say, I keep putting you in check, you're getting pressured, but you don't
Hmm.
have any time pressure.
Hmm.
You can take as much time as you want to kind of plan out your moves and do whatever you like to
Oh.
protect your king. But say you have a time limit, say you only have 10 seconds left and you're struggling to make a move, you have to make a move every like zero point 0.2 seconds, zero point 0.3 seconds. You
Hmm.
don't
Hmm.
have
Hmm.
time to react. You don't have time to plan. And so the
Hmm.
goal is rather than with, stealth and pure strategy, the goal with hypersonic weapons and the reason for this paradigm shift is now we're able to harness the power of very high speed vehicles, hypersonic vehicles and missiles in the upper atmosphere to basically drastically reduce the reaction time that foreign countries or adversaries have to deter any sort of threat. And so this is kind
Okay.
of the reason for the paradigm shift. So it's
Okay.
a rapid increase in this sort of technology has led to this shift.
Hmm. Because sometime back I remember, yeah, you are correct, because sometime back I was hearing about this F-35 jets. They just move around 1.2 mark or 1.1 mark, and they, because there is a compromise I think between speed and stealth, so they wanted to make it like, I don't know, means like it's about, they were mentioning about, in order to make it much more stealthy they have to reduce down the speed. And they were talking about this material consideration also, what happens if you go at very fast mark. So what happens is like you heat up the vehicle, there'll be radar signature, infrared radar signature of your vehicles directly if you are moving very fast. So yeah, you are correct in that way. So apart from that, let's about hypersonics, let's come back again to hypersonic materials. But you mentioned about those materials, but what are their manufacturing? Are they you because I know means like carbon fiber, if you talk about composite materials, carbon fibers, their manufacturing is very intricate. If you are talking about aerospace grade carbon fiber materials, it's like cumbersome, time taking, pain.
Mhm.
So what about these materials which you are building on? What is their processing, how much time it takes, whether it can be mass manufactured or not, these factors?
Yeah, so I don't know about the mass manufacturing stage. The materials I'm working with aren't yet Um, it's still not in the industrial process, so it's still in the research phase. Um, Personally, if I want to make a polycrystalline sapphire disc, um, it takes me about a week almost. I have to sinter this, obviously. The sintering process is basically I pack it into a graphite dye, this aluminum oxide powder, and I heat it up to a very high temperature, about zero point 0.8 times its melting temperature. So the melting temperature of aluminum oxide is it's over 2200, and so I take it almost to almost 1800 1900 C Celsius, and so that process can take probably an entire day. Um, and afterwards, the post processing takes even longer. And so making sure it's completely transparent requires a lot of polishing, grinding, a lot of post processing delicacy and artwork that kind of goes unsaid. And so it's a lot of finesse there trying to get it to its maximum transparency. And so the actual process takes quite some time. Um,
Okay.
and that's generally the case with a lot of these different hypersonic materials. And that's why it's so sought after, is because working at these temperature ranges and these, aerothermal regimes is inherently very difficult. And there's a reason for that. is because materials don't want to, exist in their normal states at those kind of temperatures, at those with those kind of reactions around them. And so it's very hard, even in the laboratory, to kind of deal with those simulated environments. And so there's a lot of hurdles that we are still trying to overcome in general when it comes to hypersonic material manufacturing. But again, I think this is a very unified effort in terms of the U.S. government, as particularly the Air Force and Space Force, when it comes to hypersonic um, research and development. And so a lot of emphasis is being put on it. And so hopefully within the next decade, 2 decades, all these processes will become more streamlined, will become more developed and processed, such that you know the turnaround is very quick when it comes to manufacturing.
Hmm. So, but we hear about a lot of like if you talk about rocket engines, a
Hmm.
lot of aircraft engines, also a lot of industries are deploying 3D printing solutions for that. Do you think there are prospects of 3D printing solution for hypersonic materials?
Yes, there already is actually. So that is kind of under the realm of 3D printing or additive
Hmm.
manufacturing. So
Hmm.
that's an entire realm of material science and engineering
Hmm.
um, that has caught on a lot of interest recently because
Hmm.
of its ability to be very precise in
Hmm.
the microstructural components of particular materials.
Hmm.
And by changing and affecting the microstructure of particular materials by the atomic layer, we can influence the type of material and thermal or electrical properties that the materials will exhibit. And so this is kind of the general principle of additive manufacturing. And
Hmm.
so it's very popular and is there's a lot of promise in the field. I personally don't work in that field, but
Hmm.
I have a lot of research colleagues, and
Hmm.
I've read a lot of promising articles in the field as well when it comes to these
Okay.
particular types of research.
And I hear, let's talk a bit about Purdue. Purdue as a place, it's a kind of a, whenever I see related to aerospace, Purdue do a kind of, cutting edge in all the aerospace related fields like hypersonics, materials and all. What do you think means like compared to other universities, what Purdue has special in aerospace related technologies that attracts students like you who are from military and all, means like I have few friends to Purdue.
Hmm. So the first reason I joined Purdue and I applied for Purdue, it was the first school I applied for. It was the first school I wanted to go into. It was my highest
Hmm.
priority school. The reason is for the aerospace program, and then
Hmm.
also is for the ROTC program. So Purdue has a very big ROTC detachment, especially for the Air Force,
Hmm.
and so it has over like at this point over 250 cadets,
Hmm.
and so it's one of the largest in the country, and they have a lot of
Hmm.
resources. They do a lot of training, and it's one of the
Hmm.
best as well in the country. Combine that with a very good aerospace degree and the facilities they have and the Armstrong Hall of Engineering and the Boeing Wind Tunnel, um, and the amount of professors and knowledge that they have here on campus. Um, it's it's probably one of the best universities you could go, for someone like me who's interested in these kind of applications, especially for the military.
Hmm.
And so this is kind of what brought me to it, and is likely what brought a lot of people like me as well with this kind of interest and my kind of passion. So.
Tell me about, let's relax the conversation from more nerdy to like less nerdy and casual.
Mhm.
What about, what's your opinion about India? Have you been to India? Because your family were from India and you born in Madras, and when did you come to US and became US citizen? And
Mhm.
what did you ever went to US India, and what all your, what did you see and how do you compare different kind of cultures?
Yeah, so I'm an Indian,
Hmm.
but I came here when I was 13 months. I was born in Madras. My family is from Tamil Nadu,
Hmm.
but I grew up here. I grew up in the East Coast,
Hmm.
and I've been to India a couple times,
Hmm.
mostly to visit my mother's family,
Hmm.
mother's parents. But recently, we have brought them over to this country, and so for the past, I think, 10 years, 12 years, I have not visited India actually. It's been a long time. I plan to go this coming fall, this coming winter in November,
Hmm.
for a wedding for one of
Hmm.
my fiance's cousin brothers. So I'm excited to go again after a long time. But yeah, I haven't been there for a long time. But despite being an American citizen, my parents became citizens, I think, in 2006 or 2008, something around there, like mid 2000s. And
Hmm.
I became naturalized, basically by my parents. Once they
Hmm.
became citizens, I became
Hmm.
naturalized by birth.
Hmm.
And so, yeah, I'm a U.S. citizen. I joined the U.S. military. Um, but culturally, I'm a Hindustani. So
Yeah.
yeah, there are not too many people like me, actually, especially in the military. And so I think I'm
Yeah.
kind of in like a unique position. I
Hmm.
practice Sanatana Dharma. Uh,
Hmm.
I consider myself Indian, but I am
Hmm.
through and through American. I grew up here, and I'm grateful for the opportunities that this country has given me and my family,
Hmm.
and my grandparents.
Hmm.
And so that's kind of my position.
When you see videos, means that you may have friends like us who are from India and who are not a citizen and who are your friends. What do you hear about India and what's the trajectory of their growth? How do you compare different kind of culture? Like Indian culture is more vibrant and all. Means like it's so much diversity. Means like when you come to US, you realize that. For me, I realize like why India is so beautiful in
Hmm.
even in a chaos of 1.4 billion people, there is
Hmm.
some organization and I believe some beautifulness or beauty in that. So what do you feel about that? Means like related to the Indian culture.
Yes, there's always harmony in chaos, right?
Hmm.
India does a good job with that. So,
Hmm.
from what I've heard from the Indian international students that I've met
Hmm.
here,
Hmm.
and other folk in general,
Hmm.
um, India is doing pretty well recently,
Hmm.
especially in the last decade, probably since Modi came into power,
Hmm.
is what I've heard. And so
Hmm.
it makes me very happy to
Hmm.
see my mother country basically doing well, and because I think in the age when I was born, that time, it was not doing well. There was a lot of inflation. There was a lot
Hmm.
of corruption. There is still a lot of problems in India,
Hmm.
but I think a lot of people are becoming more and more empowered, becoming more passionate, and
Hmm.
embracing their culture more, uh, having more sense of national pride. And I see that
Hmm.
in a lot of people, uh,
Hmm.
especially those who come here. And so I think that's very good. It's very nice to see, and hopefully in the next several decades, India can be in a much better place. And the alliance between United States and India, United States has a lot of technological prowess. It has a lot of resources, natural resources first, but it has a lot of connections and reach in many different parts of the world. Now, India, has a lot of natural resources too, but differently than the U.S., they don't have as much technological prowess, I would say. But that could very likely change soon. But they also have a very I would say, a very clear vision, and they have a lot of people, 1.4 billion people, with all, various cultures, various backgrounds, but all under one, denomination, as a Hindustani. So
Hmm.
that is something very different that the US also doesn't have. So
Hmm.
I think, like, the alliance between the United States and India is something
Hmm.
it's very powerful.
Hmm.
India, I would say, is like like the chariot, has the charioteer. It's like and is able to guide,
Hmm.
basically this new technological path.
Hmm.
And the United States is like the horse, like a workhorse, and so it's very strong, very capable, and is capable of leading. And so that's kind of how I see this harmony between the
Hmm.
two countries so far. And this kind of harmony exists within other countries as well. But I think this
Hmm.
analogy kind of helps.
What about means like a lot of when we hear Joe Biden and other, even though those who are Republicans or whether they are Democrats, they talk about this thing called biggest and the oldest democracy they consider US, but India is actually the oldest and the biggest university, biggest democracy, sorry, biggest democracy. And in terms of democratic principle and ethics and these things they also match. Do you think right so one of the thing which Indians are a lot more curious about is like US is right now these days are more inclined towards Indian principle, Indian democracy, but whether this will be possible 20 years from now or not, what do you think about that? The
So let me ask you a
alienation,
question.
yeah. Go ahead.
So what are you referring to or define like Indian democracy? So what how is it how do you see it as different from the democracy here in the United States or from other countries?
No,
Because I am unfamiliar.
okay, democracy in both a ways, like empowering people. Like when you have a strong middle class, like India has a strong middle class, 400 million people, more than the population of US are the middle class of US. When you have a good middle class in US also, you have a strong, powerful, good earning middle class. So it's both of them are the strong democracies. So what happens automatically by virtue, both of them should be aligned geopolitically also,
Mm,
and they are aligned as of now. As you can see, India and US right now, they are a lot more policies together, a lot more collaboration in every possible field. I can see I am a part of uh, government of India, Department of Science and Technology, similar to NSF over here. I am funded by them, and I came here in Purdue University from their program. They fund me. So it's like more of these collaboration are increasing between startups, between every possible thing, even in technological field, geopolitics, everywhere. So a lot of people in India are curious about whether this is just for few years because they need to cater China's growing influence, or it will be forever like this. So this is the question which I want to pose to you. What do you think? What's your point of view?
okay, so ask the last part of that question again.
So I'm saying the good relationship which India enjoys with United States right
Hmm.
now, is it just because of China, or it will remain like this for like 20, 30, 40 years?
Mm, so I think mutually right now they have a lot of benefit as an alliance, obviously because of China. You know,
Mm,
so India has a lot of competition with China, their nearest neighbor, but US also has direct competition with China. They're our biggest adversary right now.
mm,
And so as far as the alliance, I would say at least for the next decade, multiple decades, there is benefit to having, such an alliance. But whether it will be like that long term, like I said before with that kind of charioteer horse example, I think both countries have a lot to gain from one another. And I think India has also been improving a lot in the past couple of decades. And so, this is just obviously my opinion, right? None of these opinions reflect like, directly from like the Space Force or military. And so, I think in the future, such an alliance would be good because each country would kind of bring something different to the table. US has a lot of has a very strong middle class. It has a lot of diversity. It has a lot of natural resources and technological prowess. You know, then India has very clear vision, has very rooted principles and culture. And then this is something that the United States doesn't have, right? US is actually a very relatively new country. It was only founded, a little over 250 years ago. Whereas India has been there for, over 6,000 years. And so India has a lot of history. India has a lot of potential as well. And so this is kind of where I see the alliance between the United States and India going. But definitely temporary for now because both are mutually against China. But I think there's a lot of potential for some sort of permanent alliance in the future that transcends more than just a few years.
and I think the people to people connect right now, if you see number of students coming to United States is increasing, number of people who are getting US citizenships are increasing, Indians particularly. So
Hmm.
definitely with future there will be much more people to people connection. I can see right now, I can see some of the statistics which talk about like Indian American constitutes about 1% of US population, but they pay 6% of the tax
Hmm.
in the United States economy. So in that way means like there are things getting improved. So let's talk more about like when let's talk get back again on the track about from like casual conversation.
Hmm.
What about like you mentioned you are a part of US Space Task Force, which was previously there was no such agency, but it's a part of I think US Air Force. There are
Hmm.
some people from US Air Force going in US Space Task Force. What are the objective why it is created? Like initially speculation from the news channels which I can see in India and all over the world and Europe, they were talking about there was some, it is the objective was to safeguard the space, in a particular way, and about and apart from that, UFO sightings also. So can you tell me more about US Space Task Force objective and why it is created?
Yeah, so basically the Space Force was created in December 2019. It was the first ever, independent space branch in the world. It is one of the 8 military branches now for the United States, and it's a sister branch to the US Air Force. What happened basically was the Air Force had originally Space Command and Space Operations Command. And so all of the assets inside the space operations domain completely separated and made and became distinctly what is now the United States Space Force. And so the reason for this obviously is because it's in this day and age, nothing can be done militarily without the presence and protection of satellites and ground to satellite communication. And so the United States, along with many other countries, have so many space assets and space prowess, and this includes cyberspace. So space and cyber technologies and military prowess in those domains are arguably more important than kind of prowess on land or sea domains. And so this is a very new kind of a warfare domain that involves, protection, that involves, cyber attacks, satellite attacks that can potentially harm, thousands or millions of people. Imagine an entire country in which you cannot use cell phone service or in which you cannot communicate through certain radio frequencies. But these kind of threats are very important, and all of these threats originate from space. So it's very important to protect these space assets and to also have preventive measures from these assets being harmed by various other countries as well. And so that's why kind of the Space Force was created. It was a very visionary approach when it was created. It was put forth by President Trump in 2019. It was the first one of its kind, the world's only independent space force. And so here in the United States, a lot of people kind of don't know what the Space Force is about, but because it's a very new branch, many aspects of the military, like the Army, Marine Corps, these go back, really hundreds, if not thousands of years. You know, the Navy is very thousands of years old, the concept of the Navy, but the concept of the Space Force is very, very new. And so hopefully all these, explanations kind of clarified. But when it comes to the Space Force, a lot is still being developed. There's still the Space Force's own doctrine and paradigm that needs developing, and that will come with time. People like me and my colleagues in the Space Force, we will be, you know, likely one of the first group of people to kind of set forth, what is to be expected, what is the standard, and kind of set a vision for the next generation. And so it kind of all starts now. So there's no better time to be alive, So the best time is always the present.
So
So this is
what
kind of
all
what, yeah.
are, yeah, what all are under the realm of Space Task Force, Space Force? So that includes, protecting satellites. Is it about a threat from adversary countries, or it includes the threat from outside world?
So the primary mission is protecting military air and space assets, um, and that also includes basically those ground-based assets that communicate with those space-based assets. And now, what was the second part of your question, Mahindra?
So I was asking whether it's related to protecting from adversary countries, or it's from outside world, outside universe, like those
Mm,
alien kind of stuff.
So mostly it's from other countries. Now,
Hmm.
the space domain when it comes to the Space Force is not so much the same as NASA's, for example, National Aeronautics Space Administration, right?
Hmm.
So they are focused more with like data research and technology from, like beyond Earth, right? So Moon, Mars, beyond the solar system. But when it
Hmm.
comes to Space Force, mostly their focus is, space-based assets that have direct influence
Hmm.
on military ground-based assets.
Hmm.
So for example, satellite technology as it pertains to telecommunication,
Hmm.
or radar or GPS navigation,
Hmm.
and because these kind of data, is then put in enforced on aircraft and vehicles, ground-based vehicles, and ground-based vehicles as well. And so all of these kind of fall under the space domain as a result. And so that's kind
Uh,
of what the Space Force is responsible for.
And what about in the news? I see a lot about UFO sightings.
Hmm.
Is there the objective? Is the objective of Space Force also includes this UFO sightings or not? Because I remember when I heard about US Space Force, the picture in my mind was to build something against UFO sightings and all these thing extraterrestrial phenomena. I don't know whether it was advertised like that, or I heard it like that because of Star Wars and all. So that
Hmm.
keeps on running in your mind, Star Wars and all. So what was like, is UFO sightings and all these things comes under the realm of Space Force or not?
So it's hard to say. So one, I'm
Hmm.
not too familiar with this, obviously.
Hmm.
Um, I would say most of them probably fall under the Space Force. Whenever
Hmm.
there's an unidentified flying object, which is what a
Hmm.
UFO is, I
Hmm.
think most of it falls under a certain sort of airspace, which then the Air Force is responsible for protecting.
Hmm.
So I think unless they're in space
Hmm.
or higher in the upper atmosphere, I don't think it actually falls under the space domain. So I'm not entirely sure, obviously, on this. I'm not too versed with this, but
Okay.
I think generally it would fall under the Air Force, and then it's their job to make sure that that airspace is protected and is monitored. And so that's what I can say about the UFOs or UFO
What can you tell
sightings.
about UFO sightings and all? Are they real, or are these sightings actual? Because there are a lot of speculation all around, and even classified papers which we can bring out from the internet. So about UFO sighting, and again shooting down, regular shooting down of this UFO. So what are
Mhm.
these? Do you think it's actually UFOs, or there are other speculation, other theories around that?
So I would say, I mean, most of these UFOs are most of them I think are weather balloons actually, or they
Hmm.
could be from like some other country trying to spy
Hmm.
on us, which is
Hmm.
obviously like a threat to our airspace
Hmm.
um, and our air based assets.
Hmm.
So I think most of them are most likely internally, right? So the
Hmm.
chance that they are aliens, I don't know, like, and even if I wanted to say, I don't even know if I could. And so
Hmm.
yeah, I don't. I mean, the it would be really interesting to see. There's been a lot of information that's been declassified from like the Pentagon and from different bases across the country. Um, but when it comes to these UFO sightings, it's been declassified and said that most of these are actually like weather balloons or different kind of like spying satellites or spying like aircraft from like various other countries. Some of them could also be like drones. But then again, like I don't know too much on this topic, so I'm not able to say too much. But yeah.
Okay. Because there are a lot of documentaries on history, National Geographic, about these UFO sighting where US Air Force people, when they are flying like F-35 or F-16, they have clicked pictures, and they have seen those disc,
Hmm.
majorly it's like disc, like on their radar. Some of the these so some of them were some reflections in the radar, so some of them were anomalies in the radar, that what they have seen. But there are some related to, they have clicked the pictures and all, and these are available. So depends on, means like things will be clear after some point of time, maybe 5 or 6 years, when technology evolve. Okay. So but you don't believe there is an existence of aliens flying around in all over the space of all the countries right now? What your
Well,
intuition says, just
let
about
me.
it?
This is my personal belief, right? I
Hmm.
think there are aliens.
Hmm.
I It's hard to believe there are not aliens in this
Hmm.
universe,
Hmm.
right? That's just me personally. But I
Yeah,
don't
that's
think they're around flying in our atmosphere.
okay.
And
Okay.
if they were, we would easily know if they existed, you know?
Maybe their
Like,
technology is so advanced that even US military prowess can't be able to achieve that, you know
yeah.
is it possible?
Mm, I mean, it's definitely possible. If there are aliens and they've come to this planet, right, from,
Hmm.
who knows how far away, their
Hmm.
technology is most likely like so advanced that,
Hmm.
we probably can't even see them or cannot detect them of any sort.
Hmm.
So, I mean, if they wanted to be detected, then they would be detected. But
Oh,
if they're so advanced, then how would we even know that they're there, right? It's like
that's true.
no one knew what the atom was, before
Hmm.
like we had this like concept, right?
Hmm.
No one could see like different like bacteria or like molecules.
Hmm.
Only when the telescope and microscope was invented, that we were able to like see these things, right? But so many people, the whole time it was basically considered like not there or invisible, right?
Hmm.
And
Hmm.
so maybe
Okay.
they're there. I don't know. Personally,
Hmm.
I think it is very it might be likely that aliens exist in somewhere in
Hmm.
the universe. I don't
Hmm.
think we're alone.
Hmm.
But even if they're here on this planet,
Hmm.
I don't know. I don't know
Okay.
if they're here, or if they are here. I don't think we'd be able to detect them.
Okay. So there was, I don't know whether you can talk a bit more about that or not, but it was all over the news when there was a spy balloon from China and US used F-22 Raptor with the infrared guided missile
Mm,
to, you know, deflate it, or what do you call it, destroy it. So
yeah.
was it actually from China? China said it, like it's there, it flown by that way, and there were few sightings in India also, because it's
Hmm.
India, it's different, it's difficult to for a balloon to go to India because there is a Tibet region. So but people have spotted Chinese balloon on Japan, as well as like in Taiwan area, Japan, as well as right now you can talk about in US also. What are
Hmm.
these? Can you highlight something, put a light on these things? What's going on? Why there is a need for China to spy on United States?
I mean, so I don't. So obviously, China needs, and United States are adversaries right now,
Hmm.
and China gets a lot out of gaining technologies and information from the United States as well as countries like India.
Hmm.
And so it's definitely believable. They have these spy weather balloons and various different types of UFOs
Hmm.
that they deploy and send in order to
Hmm.
get this kind of information from various different countries.
Hmm.
Uh, and so I guess that's all I really know about it. I don't know too much about
Hmm.
um, the Chinese weather balloons and spy balloons.
Oh,
Um,
you don't want to talk about it because
no,
there is
it's not
some
that.
classified
Yeah.
information. Okay.
I mean,
Okay.
I'm just a first lieutenant. Even if there is, no one's gonna tell me. So I'll be honest.
Okay.
So
Okay.
yeah.
Okay. Okay. That's cool. Let's
Hmm.
come back to hypersonics. You were mentioning about these sophisticated instruments which are protected by what you are designing. So what all mechanical testing you do in order to make sure, okay, they are sufficiently, you have said one statement, mechanically robust. What's the meaning of mechanically robust? Is it you are talking about hardness or strength testing, impact, what all you are
Hmm.
talking about?
Yeah. So that refers to a couple of things. One, it refers to the flexure strength,
Hmm.
and also to the hardness, and so both are both are important
Hmm.
when dealing with a hypersonic environment. Ceramics are
Hmm.
known for their very very high compressive strengths.
Yes, yes.
Take for example like concrete. Right? Concrete on bridges and roads, is capable of
Hmm.
compressing, handling a lot of compressive stress because of trucks, cars,
Hmm.
different tractors, and all these different
Hmm.
vehicles. So ceramics are very well known for this, but they're also well known for being very brittle. And so when there's
Yeah.
tensile stress applied on them or some sort of flexion, then they break very easily. And so it's important to kind of minimize this weakness in ceramics, because
Okay.
the way ceramics break is dependent on their maximum flaw or minimum flaw size. So
Hmm.
the most, the fewer amount of flaws you have in the material, fewer cracking,
Hmm.
basically
Micro
this,
cracks.
yeah,
Yes.
microcracks, the less chance there is for it to permanently break. Basically it's
Hmm.
like a weakest link. You don't want to have a weakest link, you want to have a
Hmm.
strong link. Like at least if the weakest link is strong, then the whole material is strong, or it's at least stronger. So that's kind of the goal here with mechanical strength.
Okay, but you were mentioning about this thing. Is boron carbide also ceramic? Like boron
Yes.
carbide they use for cutting purposes, cutting the tool, cutting some materials and all. Are they
Yes,
also ceramic?
carbides, nitrides, sulfides,
Okay.
oxides, all of these are ceramic materials typically.
Okay. So
Yeah,
my question was, in order to achieve, if you want to achieve, whether there is a compromise, for example, if you want to increase the flexure strength or some bending strength, do you have to compromise on the hardness, or do you have to compromise on its compressive strength or not? Is there any trade-off, or both are, independent
So
of each other?
actually, so really what the trade-off would be is
Hmm.
it is transparency. So the way it
Okay.
works, right, if you want more mechanical strength, right,
Hmm.
then you need the presence of more grain boundaries in a particular material, right? If you have, like single crystal sapphire, for example, has no grain boundaries because it's just one crystal.
Hmm.
Uh, so it's very weak mechanically. Now I deal
Okay.
with polycrystalline sapphire, which
Hmm.
has many individual grains, like kind of like if you're looking at like a bathroom tile,
Yeah.
has like a lot of small, small grains, kind of like the shower floor you have in many like Indian bathrooms,
Hmm. Hmm.
like they're kind of just to like imagine, right? Versus like
Hmm.
a piece of just glass, like on a window. And there's
Hmm.
no
Hmm.
like small grains. It's all just one like thing. So
Hmm.
it breaks very easily. But if you have
Hmm.
like a lot of small, small grains, then it becomes
Hmm.
stronger as a result.
Hmm.
Now, the issue with that is light has to be transparent through all of those grains as well. It has to travel a longer distance. There's also
Hmm.
more chance for it to diffract or reflect and scatter.
Yes.
And
Yes.
so you
Because they are
lose a lot of
involvement of,
transparative properties.
yeah, because they are involvement of multiple surfaces, so
Hmm.
there is a higher probability of it to be reflective from. It's not necessary like the refractive index of all the grains would be same, because it's not possible, and reflection transmission depends on these relative refractive indexes, I think.
Yes.
Yeah.
Yes, all these would add up and overall would reduce the transparency of the material. So the balance is to make a material that is strong but also transparent. So this is
Hmm.
like the engineering balance that we're
Okay.
looking at.
Okay. Okay. And what means, like, in your research, when you are building this mechanically robust, or what you call it, transparent materials for hypersonic application,
Mhm.
what is the bottleneck what you think, okay, this is the place where I every time I feel like this is the most challenging place in the entire research? What is that bottleneck, and what are the main challenges around this area?
So honestly, the bottleneck is making the product, making the sample, right?
Hmm.
Because once you have your sample, you
Hmm.
can play with it, you can test it, you can do a
Hmm.
lot of,
Hmm.
um, various different measurements, get a lot of data from it. But
Hmm.
actually making the sample, especially in materials engineering, if
Hmm.
there's any materials engineers watching,
Hmm.
kind of like the struggle it is because
Hmm.
you're very dependent on, equipment and a lot of different tools at your disposal.
Hmm.
And so actually making these samples, using a giant like sintering furnace that has very like is very complicated and has many working parts, making
Hmm.
sure all of them work together is a scientist's job. So it's not just research and data collection that is part of the scientist's job. It's
Hmm.
also being an engineer and also like working on these different moving parts to actually make the product. And
Hmm.
so I'm working on both ends basically. And I would say that, getting the product and making it in the first place, making sure the furnace, and everything and the temperature and all these different, programs that I write for it to run in the proper way, that is probably the most difficult part. That is probably the bottleneck. Because if I were to just be very comfortable and, or say it was like a very easy process, making the sample, then this would be no trouble at all, right? But
Hmm.
because making the samples themselves, the
Hmm.
whole process of going to very high temperature and high pressures,
Hmm.
that itself is very difficult. And so that is probably the bottleneck. Like
Okay.
I can compare it to maybe like, like quantum research, or
Hmm.
like for nuclear fission or nuclear fusion, right?
Hmm.
Like what would you say the bottleneck is for that? Is like
Yeah.
obviously going through the process, right? But then once you have it, right, getting all the data and like, analyzing it and
Hmm.
looking at it and doing the research, connecting the dots, that
Hmm.
becomes easy. But
Hmm.
you're heavily dependent on what the product looks like and how you make the product. And so that is kind
Okay.
of the main bottleneck, the main trouble,
Okay.
with this
Okay.
kind of research.
That's great. That's great. When are you graduating then? What's your plan
Um,
for the graduation?
yeah, so right now I'm set to graduate in December of this year.
Hmm.
So another, 6, 7 months, and
Hmm.
I'll be done, and then I'll be moving on to the rest of my Space Force career. First, I'll be going to undergraduate space training in California.
Hmm.
And after that, I'll most likely move to the East Coast, back to Virginia,
Hmm.
for to be with my fiance,
Hmm.
uh, as well as start my Space Force career there.
Okay.
Hmm.
So thank you. We can end this, and you also have to go. Thank you for thank you so much to coming to my podcast and finally making it through. I know you are very busy, so thank you for your giving me your time.
Yes, of course. Thank you, Mahindra, for inviting me as well. And I'll just say one more time, these are all like my personal opinions. None of these reflect the actual official opinions of the Space Force or Department of Defense or US military. So, yeah. Thank you very much for having me.
I will put
I
the
very much
description
appreciate.
below that happens in the movie,
Yeah.
every
Yeah.
movie. Okay. Okay.